In this next section, I'll be talking about serverless functions in Kubernetes. First of all, what is serverless? Public cloud providers often provide serverless capabilities in which you can deploy functions rather than instances or containers. Microsoft has Azure Functions, Amazon has AWS Lambda, and Google has Cloud Functions. So those are the main public cloud providers, and they provide all ways to deploy functions. With these products, you don't need to manage the underlying infrastructure. You just only deploy the code, the function that you want to execute. The functions are also not always on, unlike containers and instances, which can greatly reduce the cost of serverless if the function doesn't need to be executed a lot. So you also pay by invocation rather than by minute or by hour. So it makes a big difference in the pricing. Serverless in public cloud can reduce the complexity, the operational costs, and engineering time to get code running. You don't need to manage a Windows or Linux distribution. You don't need to build containers. You only pay for the time your function is running. So if your function only runs for 5 seconds, you will only pay for those 5 seconds. A developer can just push the code and does not have to worry about many operational aspects. Although cold starts, the time for a function to start after it has not been invoked for some time can be an operational issue that needs to be taken care of. While it reduces the operational workload for the engineering team, it also brings some new problems that you have to take care of. And those cold starts are one of the main issues that you have to keep an eye on. So serverless reduces the complexity because you can just deploy code rather than containers or instances with libraries and binaries and so on. It can give you lower operational costs because you're built differently, and the engineering time to get the code running can be lower because you only need the code and the runtime is provided by the cloud provider. This is an example of an AWS Lambda function. So this just contains 3 lines of code. You just define a function that takes the event and the context, which can contain information about how the function is invoked. And then you pass hello world. This is the result of this function. You would still need to set up when the code is being executed. So now you have a function, but you still need to set up when it is going to be executed. For example, in AWS, you would use an API gateway to set up a URL that will invoke this function when visited. So what I showed you here, those 3 lines, is just a function. It doesn't tell you when it should run. You need to connect it to another AWS service, for example, the API gateway, that will give you a host name, a URL, that you can then invoke just by browsing to this URL. And then you can link this function to it, so this function executes, and then it would return hello world. And that's what you then would see in your browser. So there is still some operational work to get this running. Now, serverless in Kubernetes. Rather than using containers to start applications on Kubernetes, you can also use functions, like the AWS Lambda. Currently, the most popular projects enabling functions are OpenVAS, kubeless, Fission, and OpenWhisk. So all those projects are providing ways to run functions on Kubernetes. You can install and use any of the projects to let developers launch functions on your Kubernetes cluster. As an administrator of your Kubernetes cluster, you would still need to manage the underlying infrastructure. But from a developer standpoint, he or she will be able to quickly and easily deploy functions on Kubernetes. This is the major difference with public cloud. Within public cloud, you don't have to manage the infrastructure. This is done for you. But because you are running Kubernetes, because you are installing one of these projects, you still need to manage this serverless infrastructure, but then your developers can use it just in the same way as they would use it on the cloud. All these projects are pretty new as of September 2018 when I created this lecture, so their feature set will still drastically change. Most of the projects are also still in alpha status, so some of the existing functionality can still change as well. If you are looking in adopting a serverless technology for your Kubernetes cluster, it's best to compare the features and the maturity of multiple software products and make your own decision. So all of these projects have a GitHub page. You can go to their GitHub page, read about them, and compare their features with what you need in a serverless technology. In this course, I will demo Kubeless, which is easy to set up and use. It's also one of the technologies specifically written for Kubernetes, and it leverages a lot of the Kubernetes components to integrate this functions capability within Kubernetes. I will talk about Kubeless in the next lecture.